Maths Aspirants is a collective of mathematics students, teachers, research scholars across India and abroad. Started in the year 2017, and we used to arrange online problem solving sessions and test series to help the students who prepare for different national level competitive examinations. As a part of that online problem solving session series, today we blessed to have Dr. Nivetha Martin, an assistant professor of mathematics, Arul Anandar College, an autonomous institution in Madurai, Tamilnadu, to engage a session on selected problems from integral calculus. As all of you know, calculus, there will be a lot of questions from the area of both differential as well as integral calculus for the exams like IIT JAM and other PG entrances. So today, Dr. Nivetha will discuss with you a few good problems from the area of integral calculus. I would like to thank Dr. Nivetha for accepting our invitation. Actually, she had 2 sessions last year in our platform, and she is really a great contributor to Math Aspirants groups. She did Ph.D. from Bharathidasan University, Tamil Nadu. And I welcome everyone to today's session. I hope that this session will be really helpful in your preparations for competitive examinations. Welcome everyone. Welcome Nivetha.
So warm greetings and wishes to everyone who have joined virtually. So now I'm so happy to be a part of this Math Aspirants. Really that the Math Aspirants is doing wonderful job under the able guidance of Sir. So because of his initiatives, we are able to connect with so many students, and so many faculty members are also taking lots and lots of efforts, mainly to share their knowledge and to make the students understand about how to handle the problems in the competitive examinations. And today I've just got a chance to discuss a few problems on integral calculus. See, as Sir has rightly said that in your JAM, you'll be having a lot of questions from your differential calculus and integral calculus. So now what I'm going to do is, in 2023, few problems have been asked in your IIT JAM there. And what are some anticipated questions? What questions you can prepare, and what type of questions maybe you can expect in your examinations. No? So that it is going to be an anticipatory problems. That also I'm just going to have a discussion about that. So simply to throw a light, because everyone is very well aware of what is the integral calculus, but a few students maybe now learning it, or maybe need a better idea of what is calculus, and especially the integral calculus. So you know that it is a branch of calculus, and it is basically you go with an integration. See, the basic idea of integration is just to find the area of a surface, or to find the area of a particular region. So whenever you go on with your integration, it is some summing up. So you can always go with the summation concept for the random. Okay, you just go with those particular one, that is for the discrete values, you just go on with that. And if it is going to be your continuous values of your input, so you can able to go on with your integration. So that is a basic idea that everyone knows of it. But actually, you have to know that another one aspect that you know very well, that the integration is going to be a reverse process of differentiation. So what is actually an integral? So as I said earlier, it is an area under a curve. So you are just going to find an area of a specified region. And here it is a very simple example I just have given here. And there are different types of integrals. So here we are going to have the major types are the definite and indefinite integrals. So definite integrals, you know very well, the representation is that maybe if you are going to find the value of f of x from the limits, that is from your a to b. So your integrating variable of x, it takes from your values. So you know the definite values are there. But for us in indefinite, which is not having any upper limit or lower limit, we are just doesn't know with that. So you just take that it is going to be an indefinite integral. So these two aspects are very much needed. And then another one, it is a fundamental theorem of calculus. So this is very simple, that if we are going to find an exact numerical value, it is not simply the integral alone you are going to find the integral value, but it is going to be more of a numerical value it will be there. So we will be generally applying this fundamental theorem of calculus. And there are some properties are there. So these properties will be helping us in order to solve the problems at that time. So they are very simple. You go with your linear, you go with your actually the integrals of the same functions of it. Then we know very well that the differentiation integrations are the reverse process. Also using the integration by parts and integration by substitution, some trigonometric identities and partial fractions, and some particular functions you have the integration. And this is something about you will be dealing with your double integrals. So double integrals with respect to two variables you will be taking. So it will be like your f of x comma y. It is a region over that. And then you will be having about the volume integral. So volume integral, you go with your three-dimensional one, where you will be having your x, y, and z. So integral calculus, no, there is nothing that you want to learn something very new in the sense, but rather you will be able to make a remembrance of what is all about your integral calculus. So what type of problems you will be getting in your IIT JAM? So what type of problems they are asking is, most probably they are asking about your double integrals and your triple integrals they are again asking. And then where you have to apply the change in order of integration. So this is also equally very important that. So you know very well that if you're going to integrate a particular function, first with respect to x and y, will be giving you the same result when you're going to integrate with respect to y and x. So the changing the order of integration will not bring a change in the final result value. So these are some basic concepts that you will be just knowing about, and you have to know about your integral calculus. And here, what I have just move on with that is, I have just planned for around 22 problems I have planned, and each problems are a bit different. So we don't follow a similar approach of the problems most probably. Maybe it may look alike. The problems may look alike as though they may looking very similar, but it is not so. So my dear students, what I like to say is, so simple now, if you want to cook something, if you want to cook a food, before cooking the food, you will be getting ready with the ingredients. So that is very important. Only if you keep all the ingredients in the right proportion, then you can able to prepare the food according to the taste that you desire, according to the quality you want in it. Similarly, when you're going to deal with the mathematics, the problem solving, for solving the problems, you need some basic idea about what do you mean by double integral. So you must be well aware of the basic integration, how we are going to do that, how you can apply the limits, the fundamental theorem of the calculus. So integration may be simple, it may be a bit difficult. Sometimes it will be complicated. So the complication can be resolved by different methods of integration, like substitutions and integration by parts or partial fractions. So you must be a little bit aware of it. So since you are being in college, and definitely you'll be having all those things in your school education itself. So just a recap. Again, double integration is a kind of way, and triple integral is also a kind of way. So double integral, it is actually, it goes with your area, and your triple integral deals with your volume. So this is all about, you have to know certain basics before you venture into the problems. So what is the very first problem is, so here it has been asked the value of your double integral 0 to 1, 0 to 1 minus x, cos of x cube plus y square dy dx.
Excuse me, Nivetha madam, excuse me, could you make it the full screen? That means...
yes, sir. So I thought that I have to, yeah.
Yeah, it's correct. Okay.
Yeah.
Thank you.
So now you're going to find the value of this. See, I like to give a very small tip to you. So I know very well that the people who have joined in Math Aspirants, really they are aspiring to gain the heights of it. But what I like to say from my side is, if you're looking at the problem, please don't get panicked by looking into the way the problem is appearing before you. You just read the problem once or twice. Okay. So if you just first look at the problem now, you will feel that something that, what is this? So many components are like that, it is there. But if you just keep looking at the problem once again, the integrand is same. Okay, that is the cos of x cube plus y square is same. But what is differing is, look at that, it is dy dx, it is dx dy. So the limits what is given in the integral will be with respect to that particular variable. So for the first one, it will be y, it is dy dx. What does it mean that? the 0, 1 minus x, no? 0 to 1 minus x. So your y limit is actually your 0 and y is equal to 1 minus x. So here you are having dx dy. So the limits of x are given in terms of y. Now if you want to find the value, no? So it is a linear property if you want to use. The order of the integration must be the same. So that's very simple. So then you can able to find the values of it. So here, you are going to change the order of the integration in any of the one. Either the first one you can make or in the second one you can make, so that your integrand and of course the other things also remains the same. So now how can we do that? So this is going to be very simple with that. So since it is a very first problem, and you know very well, it is going to be the first value is actually, I say, the 0 to 1 here, and it is 0 to 1 minus x, and this is going to be your cos of x cube plus your y cube, your dy and dx. So now this I am going to change the order of the integration. So first, let me just have a plot of it. So y equal to 0 and it is 1 minus x. So just bear with me. So you just take your two dimension, it is going to be your x and its y. So y equal to 0, it is going to be your x-axis, and your y is equal to 1 minus x. So it is nothing but your x plus y is equal to 1. So it is going to be a straight line. So even sometimes we not be that much excellent, or you not be able to draw it very simply in a single line. So but then it is simply understanding, no, it is 1 minus x. So I just go from the scratch, I go from the beginning. So if you just take x is equal to 0, and you can take your y is equal to 1. If you take your x is equal to 1, you get your y equal to 0. So you can take your 1 comma 0 over here, and it is 0 comma 1 over here. So you will be just getting a line. So it's simple now. We need not worry about it. You need not get all the points which fall in the line. So you can give simple inputs to get points to draw the line. So this line is going to be your x plus y is equal to 1. So definitely the region that it will be covered is this one. Now the y limits are actually given here. Now what I'm going to do is I'm going to rewrite this one in terms of the limits. So what I'm going to do is I'm going to change the order of integration. So if I'm going to change the order of integration, so I just take, now it is y. If I want to get the x limit, so I need a dx dy. So if I want to get d in terms of my y, so I want to have my limits of x in terms of y. So if I want to have my limits, I will be drawing some horizontal strips, you know very well. So this will be 0, and this will be actually, I want to write in terms of my y. So I can get it as 1 minus y. So again, if I want to go with, this is actually 0 comma 0, and this is actually 0 comma 1. So if I'm going to draw the vertical strips now, then I can say the y varies from 0 to 1. So this is going to be 0 to 1. And here I can get IQ. Now what is the other way? So other way it is nothing but it is 0 to 1 again, and it is 0 to 1 minus y, and this is going to be your cos of x cube plus y square, and it is going to be your dx dy. So now both are going to be the same. So that's what here. So look at this one, this and this are same. So obviously you will be getting the answer is 0. So what we have done, we have just changed the order of integration, and we have just made the order of integration to be the, and finally we are getting the answer as 0. And now we'll move on to the next question. So what is the question is? The area of the curved surface. The area of the curved surface. So the surface is given. So here the surface is your S is equal to, it is a set of all x comma y comma z. It belongs to R cube. Okay, fine. Where your z square is equal to your x minus 1 plus y minus 2. Some surface actually is being given here. And now it is also being told that it is lying between the planes z equal to 2 and z equal to 3. So this is fine. Now you'll be imagining now we have to find the surface area. So that is the area of the curved surface area of this particular surface what is given here is. So now how can we do that? So here, whenever you are getting the problem of finding the surface area, and here it is very simple, you have a formula. So what is that formula is? So basically, we'll just go over some simple tricks with that. We need not much focus on doing the more steps involving in solving the problem. So it's very simple. So the surface area formula will be, this is square root of your 1 plus zx square plus zy square. It is going to be dx dy. And what is your z square is given as x minus 1 square plus y minus 2 the whole square. So this will be your 2z dou z by dou x. So it is a partial derivative of z with respect to x. So this becomes your 2x. So it implies that your zx. So zx I can write it as, it is x minus 1 by z. And similarly, we can just simply write directly for your y minus 1 by z. Now what happens here? So now that will be your double integral, your square root of, it is 1 plus your x minus 1 because zx square. This is by z square and it is y minus 1 the whole square by z square. So again you get with the dx and dy. So this becomes your double integral over z. So it is square root of, actually the denominators are same, and it is given that your z square is equal to your x minus 1 the whole square plus y minus 2 the whole square. So this becomes your 1 plus z square by z square, then dx dy. So this becomes your double integral. So I can simply say it as, it is root 2 dx dy. So this is fine. So now root 2 will be again, I can take it outside. So this becomes dx dy, area of it. See here, if I'm just going to take your z square equal to x minus 1 the whole square plus y minus 2 the whole square. And also, it is being given the planes and the values of your z is also given. Z equal to 2 and your z equal to 3. So here I can just, if you're going to look at that z square equal to something x minus 1, equals like a circle. And whereas your z values are given here, so I can just say the center is your 1, 2. So x minus 1 the whole square plus y minus 2 the whole square is equal to your z square. So z square is 4. And your x minus 1 the whole square plus y minus 2 the whole square is equal to your 9, because it is 3 square. And here, if you're just going to look at the particular question once again, you're just going to find the surface area, okay? It is lying between the planes, z equal to 2 and z equal to 3. So when this is going to be the case, and definitely, I could say that it is a region lying between these two circles. So we know what is the area of the circle here. So the area of the circles will be, okay, or pi r square you can take. So here it is going to be your root 2, since it is going to be a circular region, and that circular region is a region lying between these two circles. So it is so simple. So you can take it as pi. So it will be pi r square when r equal to your 3, when pi, again r square will be equal to when r equal to your 2. So this is going to be your 9 minus 4. So it is nothing but your 5 root pi will be the answer. So this is the way that you can able to give the solution for this problem. So coming to the next one. So here it is given, let f of x comma y is equal to, so double integral e power, some expression is given. And again, it is double integral over. Definitely it is going to be a region. And if you're going to look at that particular region, no, so that region, it's again is resembling something like a circular one. See, this is very much important of how you are identifying. So the general expression. See, the problems that most probably coming in your integral calculus, they have the touch of the circle in one or other way. So whenever you are going to have the spherical, and when they say the projection of the spherical in 2 dimension, definitely it is going to be a circle. So most probably, no, the circular representations are based problems are there. So here, Then they are asking when limit n tends to infinity, what is f of n comma n square will be. So some thing you are going to find it from the 4 options are there. So how to do this problem? So if you are going to take this problem as such, it is very, very tough. It is not that easy to go on with that. So for some problems, we always our coordinates representations or substitutions we make to make the problems very simple for computation purpose. So basic idea of using the polar coordinates is to reduce the complexity of what? The calculation part. So most probably in integration, we'll be using the coordinates, the polar coordinate substitutions. So we'll just see that what way we can make use of the polar coordinates. Okay. So look at that. The region is resembling a circle actually. So now the problem is, so this is a problem. So I just go with that u power minus x the whole square and v minus y the whole square. Then this is going to be your du dv, and here it is u minus x the whole square. Then it is a v minus y the whole square is less than or equal to 1. So now what I'm going to do is, I'm just going to take my u minus x is equal to r cos theta. So generally we take x is equal to r cos theta, but it is like u minus x, you take it as r cos theta. And you take v minus y to be your r sin theta. And then you take your du dv to be r dr d theta. So if I'm going to substitute here, then definitely I'll be getting my r square is less than or equal to 1, because it is r square cos square theta plus r square sin square theta. It is less than or equal to 1, so r square. So I can take in that case my r is taking the value of 1. Okay. So now what happens here? So double integral I'm just going to take. So it is going to be e power minus. So it is again the square root of u minus x the whole square is going to be r square cos square theta. So it is r square cos square theta, and this becomes your r square sin square theta, and du dr as stated earlier, r dr d theta. So r value varies from 0 to 1. Theta, since it is a circle, 2 pi. The entire thing you'll be comparing it. Okay. So now this happens here. So you know very well what happens to the e power expression. So this is going to be your 0 to 2 pi, and then you take 0 to 1. This is going to be r square, so it becomes e power minus r. It becomes r dr d theta. So now look, as I said earlier, polar form, it has reduced the complexity of integration. Now this is very simple to integrate. So you will be taking your u equal to r, so there will be no change in the limits. So your du will be equal to your dr, and then you take dv equal to e power minus r dr, and you take v will be equal to minus e power minus r. So you just go with the uv minus integral v du and all those things. So I just take for r e power minus r, it becomes plus e power minus r dr. So now this becomes again, maybe what I feel is, first we shall complete the theta integration part, otherwise it becomes a little complicated here. So I'm not going to worry about, just a minute. So I'm not going to worry about the r part as of now, the dr part. So let me just keep aside. Now you just to see, if I'm going to integrate only with respect to theta, I just get theta. Then if I'm going to apply the limits, I'll be getting 2 pi. So here itself, I can write it as 2 pi. So it is 0 to 1 e power minus r dr. So I think this makes us a bit easy for us to proceed with the integration with respect to r. So now I think this is fine. So 2 pi is there. And now this is also okay, 0 to 1. And of course, I want to apply the limit 0 to 1 here. So here there is no problem because it is 2 pi. So if I'm going to apply 1 here, this becomes e power minus 1. If I apply 0 here, it vanishes off. So now again, it is e power minus r by minus 1 will have. So it is again 0 to 1. So this becomes 2 pi. This becomes minus e power minus 1. You just retain with this minus outside. You have to take minus, and it is again, yeah. So what happens here? Because e power 0 is 1, so it is 2 pi. So this becomes e power minus 1 minus e power minus 1, it is 1. So again, I can take it as it is 2 pi, so it becomes 1 minus 2 e power minus 1. So this is the answer that what I'm getting it here. So it is 2 pi into 1 minus 2. The D option is the right one. So coming on to the fourth one. See, this fourth problem is something like, again, the surface area. But look here, they have not asked us to find the surface area. They have given us some other more task like that. So this problem, no, this problem that it demands a little bit of thinking, and it is a twist problem that because this is the one which fools us sometimes, with the options. We'll be just so confident that yeah, we got the right answer, but something that is a hint in it, because it is not that easy to get that answer in a jam question. I know very well that we'll be having a twist and turn. So this is one of a problem which has a twist in it. So we'll see that what is the twist is all about. And this twist, it demands a little understanding of why this option is more precise. So you are going to get only one option right. It is not too many options. So we'll see which option suits better, the best one. So here they are given that for each t, okay, it falls in a value set of values there, 0 to 1 interval. Then the surface PT in R cube is defined. Okay, what is that surface area? What is the surface? It is being given that. If you're looking at the surface, of course, it is given some x square plus y there. Okay, some surface is there. And it is given also your x square plus y square, the values from t to t squared to 1. Okay, fine. And they are just asking you what will be the surface. I think that our AT belongs to our the surface area of PT. So what is that AT values? So here it is very simple. So first, as you should know, we shall just move on to the thing. So they are asking about the surface area. So we'll see how can we go on with that. So as I said earlier, the surface is being given. Okay, what is the surface is given actually? Na? So the surface is given is to be your x square plus y square. Your z is equal to 1. Now you are going to find the surface area. So now you may wonder that, okay, already a problem has come of this type the same year, and how come it's that? Of course, the approach is going to be the same, but the analysis part of the solutions, what is given there, no, it is big different. So that is why I'm telling that though it may look alike, it is not so. The previous case, you applied the formula and you got everything set right. Okay. So now if I'm going to go with your Z, so let me first take Z on one hand, and I take the other terms in the other hand. Okay. So this is how. So this gives us a better idea of finding your ZX. So I'm going to differentiate partially with respect to x. So it's very simple. I just go with the x square plus y square, the whole square. And definitely it is going to be your 2x. Okay. So this is very simple with that. So you'll be having a negative sign also. Because this is nothing but what? This is nothing plus y square, the whole power minus 1. So when you just go with x square plus y square, again it is minus 2 into 2x. So this becomes. So what will be your ZY? Your ZY will be minus 2y. So it is x square plus y square the whole square. So look at this. So you know what is your ZX and we know what is our ZY. So what happens? So then you'll go with your double integral. That will be your square root of 1 plus. This becomes your 4x square. And again it becomes your x square plus y square the whole square. And here again it becomes 4y square. Again it becomes your x square plus y square the whole square. And here I'll be written with your dx dy. So now this becomes your double integral. And here it becomes your 1 plus. So either you can take it as your 4 into x square plus y square you can take. There is no harm in that. So x square plus y square, the whole square. And I think when I'm going to square it, I'll be getting it 4. Because already we have the expression as x square plus y square. So again, if I square, I think I will be getting it 4. So dx dy. So even I can go with a simple way. So it is going to be 1 plus, it is 4 by. It is x square plus y square the whole cube. Then go that. So it becomes dx dy. So now no, to resolve the integration part. So I'm not that much good with your integration in the sense with this expression. Then I can move on with the what? The substitution of the polar form. So you know very well that, look at the things, your x square plus y square. So here I'm just going to take a substitution of my x is equal to r cos theta, and I'm just going to take y is equal to r sin theta. and your dx dy, that will be your r dr d theta. So here, so fine. I'd like to pass here at 10. See, you have your 80 and your double integral over t. I think we arrived at this way. We already arrived this answer. So once you are getting this, because it is simply direct substitution. Na? So I think here itself we are arrived. So we arrived the answer here. So the moment you are arriving at the answer, we'll be very much happy that to say that, okay, one of the options what is given in the question paper, we have just got it. But it is not that thing. You have a little bit of having of understanding in this case only, as I said earlier. So now what they are doing is, we cannot convince ourselves with this solution. So now they are going for substitution of the polar form. Okay, what's the use of doing that? So now when I take x is equal to r cos theta, y is equal to r sin theta, so x square plus y square will give us r square. So definitely it is going to be your double integral 1 plus 4. And here you will be getting your r square here. And here I can take it as it is r square. So r power 6 it will be there. Then already you have your r and your r dr d theta. And generally, so your value of your theta will be your, and here that when you are going to go with your values of your r, of it. So here you will be getting a times of, so you can get the integration with respect to theta. So no problem, you gave it your 2 pi and all those things. But eventually when you are going with your r, when you're integrating, no, so definitely you have a lot of chances for getting your r to be what? Your denominator. So again, when you're going to have for r the values, and again you're going to go with your 0, then your t tends to 0 here, no? Because you'll be having the limit change over here. So definitely there are a lot of chances for things, the non-existence of the limit here. So here, you'll not be getting the options right as your B, but whereas your D. So this is very much important over here. And this is a place that where we are just losing the point over here. So when you're just going to go with your integration and things, and when you just go with that, so there are a lot of chances for it to have the limit not existing here, because as I said earlier, no, maybe I can just have it as no, I can simply bring it as of t2 or 1, but as t tends to 0 over here, then automatically there are a lot of chances for the non-existence of the values of your at. So this is where that we have to be a little bit conscious whenever we are getting a very simple answer. So directly you have to check whether it is right. So coming to the next question. So the value of the limit n tends to infinity and n integral over and all those things are there. So some expression is given here and you have to integrate and find the limit. So look at that, the expression is not that easy to get integrated because with respect to n it is there, the expression, the numerator. So we'll see how to solve this particular one in a simple way. So you have the procedure of solving it. So we go with the problem number 5. So let me just go on with this. So here, let me take my I alone to be your integral 0 to 1. You can take it as x power n plus 1. So sorry, it is x plus 1. It is going to be dx. So the problem is actually n tends to infinity. So it is n into, so it is 0 to 1. It is x power n. And it is going to be your x plus 1 and it is going to be your dx. So we'll have the dx. Yeah. So now what happens here? Let me take my I to be 0 to 1 x power n by x plus 1. So simple, I have to make some sort of adjustments. So what can I do then? So here, I want to have a split up of this integral. So you know very well, whenever I want to split this integral, I just multiply both the numerator as well as the denominator with x. So next, what I can do is I can add a 1. So I can get it as x into x plus 1 dx. So now I'm able to split up this integral as, so 0 to 1. So this is going to be x power n. So I think I'll be having your x also here. So x plus 1. So here I will be having x into x plus 1 because it is a common denominator. So I'll be having x. So I will be taking it as x power n. So I just take with the x into x plus 1 dx. Now what happens here? So here it is nothing but 0 to 1. I am getting retained with the x n minus 1 dx. And now this becomes x power n minus 1 x plus 1 dx. So I have taken my I as 0 to 1 x power n x plus 1 dx. So if it is going to be n, I just take it as I. And again, if it is going to be n minus 1, because it is independent of what I'm just going to take here. So I are n minus 1 dx. And here also I can take it as my I. So this I to 1 x power n minus 1 dx. So this becomes, when I'm just going to integrate x power n, because n minus 1 plus 1. So again, I'm just going to take n here. So again, I'm going to have it as 0 to 1. So I'm just left out with the 1 by n. So my 2i will be, so I will be equal to 1 by 2n. So now, but what is your question is all about? So your question is nothing but limit n tends to n into 1. So I am left out with this 1. So when I'm going to go on with the n into, so implies that your limit n tends to infinity, n into 1 by 2n. So it is left out with 1 by 2. So in some cases, whenever we are having such type of problems, then we have to separate the particular integrals and try to find the value of it. And now this is another one interesting problem. So it is given that S is a triangular region and the vertices are given. So the vertices are not given in terms of some numbers like that, but in terms of some angles, like 0, pi by 2, some radians values, and pi by 2, 0. And now they are simply asking us to find the value of it. So it is also one of the questions being asked. So we'll see how to do with that. So we not worry about it. Because imagining, we'll be giving our 0, 0, 1, 0, 2, 0 without that values. Immediately when people are giving like 0, 0, pi by 2, we need not worry about that. Okay, you just simply mark the like an axis how you are doing it. So it is very simple. So you just take it is 0, 0. So some values you take it is pi by 2, 0, and here you take it as some 0, pi by 2. That's it. Now what you do? It is a triangular region. So you are just going to connect these 2 points. And this is the entire triangle you will be getting it. Okay. So this particular region you are going to consider. Now what do you want to find? I just want to find the value of the particular integral. It is sin x, it is cos y, dx, dy. So now, first I have to integrate with respect to x, and then I want to integrate with respect to y. Now what will be this equation? This equation will be x plus y will be equal to pi by 2. So the equation of this line will be x plus y equal to pi by 2. Now I can just go on like this. So this is going to be double integral over a sin x and cos y is there. And what should I get now? Since I want to integrate first with respect to x, then with respect to y, I have to just move on with the getting the values of my x in terms of y. It is very simple. So how can I do that? So I not worry about anything. So I can take x. If I want to move on for x now, I have to draw the horizontal steps as I said earlier. So it is 0 to this line. So 0 here. So I can take it as. So I can take it as pi by 2 minus x. So if I'm just going to go on with that, then I can take it as 0 to pi by 2 here. It becomes sin x, it becomes cos y. So dx, dy. So one thing I like just to mention here. So maybe if I'm just going to take the limits of it, I think I can better make use of the order of integration change, so that it again makes me certain things very easy for me now. Okay. Or if I'm just going to take it as just a minute. Maybe with the same limits also I can get retained with that. We'll see what we are getting it. Okay. So we'll see the things how it getting changed with that. So what shall I do is first, maybe I can go on with the integrating fine. So let me first integrate with respect, because I'm getting the limits of y in terms of x. So I can just go on with that. So first we can tell like this. So I can take it as 0 to pi by 2 here. And now I can move like this. So I can take it as my sin x. So cos y, I can take it as it is going to be the sin y. And I can leave out with 0 to pi by 2 minus x. And this is going to be my dx. Okay, since now this is simple, since what I'm telling is either you can take it as in terms of your x and y, or take it in y and x. You have the both expressions, because either you can, if you are choosing your x first, then you have to apply the same things, and choosing your y, and accordingly you can do it. So this is so simple, and the integrand is also basically some simple trigonometric functions. You can go with that. So this becomes your 0 to pi by 2 here. So you are left out with your x. So you take with your sin x, and then you go with your sine of pi by 2 minus x. So again, sine of 0 will be 0 here. You are left out with your dx. So this becomes your 0 to pi by 2, and here you're getting your sin x, and this becomes your cos x dx. So it's very simple here now. And now what the next thing you can make? So next thing you can make, it is nothing but your 0 to pi by 2. As sine 2x, provided I must have 2 here. So it is sine 2x dx. So now I can just have this as 1 by 2. So sine 2x, if I'm just going to integrate, I'll be getting minus cos 2x by 2. So I think I can take it as minus 1 by 4 here. So I'll be left out with 0 to pi by 2. So I can have it as it is cos 2 pi by 2 now. So it is cos pi. So minus I can have it here as cos 0. That is going to be your 1. And here it is going to be minus 1 and minus 1. It is minus 2. So it is 2 by 4. It is going to be 1 by 2. So these were the questions that we have been asked in your 2023. And another one thing also. So this also being asked with respect to the volume. So far we have seen with the surface, and now with the volume. So now we just go on with that. So volume of the region is being given. So for which surface you are going to find the volume. The z values are given, and again x square plus y square. So the circle lies between your 0 and 1. So with that radius limit, you are getting a circle, and what will be the value of v by pi. So we'll see how can we do this one. So this is also very interesting one. It will be there. It demands a lot of computations only, nothing more than that. So I can take my v. So what is your v? So since it is a volume, you just take it as your dv. This is nothing but your dx, dy, and dz. And now you know the values of z. So is less than or equal to 1. So this is one set of values are given, and this is another one region is been given. This is another one is given. So first we'll deal with our z. So what happens here is, so when I'm going to integrate with respect to z, it is only z. So z dx dy, and it comes as your xy and 4. So you can take it as 4 minus xy. Okay. Because wherever you are getting x square plus y square, so that is a hint for us that there is a space for us to use the polar coordinates of the circle. So I can take it as x is equal to r cos theta and y is equal to r sin theta. You can take, and same thing, dx dy will be equal to r dr d theta. So in the introductory, I was telling you that so many problems, it will be dealt only with your circle. The only thing is we have to identify whether we can use the polar coordinates to simplify the process. So you know very well we can take it as 0 to 2 pi first, then take it as 0 to 1, the angle as well as the radius. So it is 4 minus. So it is r square. Because it is r, it becomes a cos theta and sin theta. So dx dy will be r dr d theta. Okay. So this is very simple here. And now what shall we do? So 0 to 1 again, it is 0 to 2 pi. So look, there is a space for us to use the trigonometric formula. So it is cos theta sin theta. So I can have this as sine 2 theta by 2. So it is r dr d theta. So it encompasses this one. So now what happens? So I think let me have a split up of this integral to lessen the computation complexity. So I can have it as 4 dr d theta. Am I right? Because I'm just having a linear property here. So again, I can have it as 0 to 1. Again, I can take it as 0 to 2 pi. And this becomes my r cube by 2. And it is sine 2 theta. This becomes dr d theta. That's it. See, whenever you are getting an integrand to be sine with multiples, that is 2 theta like that, and your limits is actually 0 to 2 pi. Of it, let me tell you. First, let me complete this one. So it is 4, I can take it as a constant. So r square by 2. R square by 2, and then you are going to apply, definitely is going to be 2. And then d theta will be left out. So when I'm going to integrate, I'm getting only 2 pi. So this will be 4 pi. Fine. And now, look at this one. If you're going to integrate again r power 4 by 8, okay, 1 by 8 you have. But you just see here the sine 2 theta. You can less the time of computing. So when the sine 2 theta is there, if I integrate with respect to theta, I'll be getting minus cos 2 theta, okay. And but cos 2 theta, if I'm applying theta to be 2 pi, it is cos 4 pi, it is positive 1, minus 1. So this integral will become 0. So this is how you want to identify whenever you have sine 2 theta with the limit 0 to 2 pi or sine 4 theta, it could be anything because it is a multiple now. And even if you have a multiples of that, even if you have 0 to pi also, you will be getting what? The same, that will be 0 here. So this entire integrand value will be 0. So 4 pi. So now they are asking you the v by pi. That is, if you're going to look at the question, v by pi is. So v by pi will be actually, your volume is actually your 4 pi you are giving actually here. This is your v. So v by pi will be actually what? It will be your 4. So this will be the right options. Your D options is right. So this is a 1. So these questions have been asked in your 2023. And now in 2024, the anticipated questions, what should be the questions they can ask it. So they may ask such questions. So we'll see that what type of questions they will be asking it. This is only a anticipated one. Not sure that whether it will be asking the same thing or not, but simply many people now out of their own interest, they are posting so many problems in the online platform. So when you are just finding time, you can just even see that what type of questions they are foreseeing it in the coming years. That's also very important. Now, look at this problem. They are asking which of the following are true. It means that there may be more than one option also will be right. So which of the following are true? So the question goes like this. So look at this one. They are comparing the integrands. They are not asking us to find the values of things. What is the value of this? No, nothing. They are not asking us to do anything. But actually what they're asking us to do is, they are simply asking us to find the unknown values and whether the relationship that is existing between the unknown values are right. So that's it. You have two unknown values are there in your right hand side. It is m and n. So but no other things are given. They have not said even a single word about your any region, something like that. Only the integrand is there, but from which you can take and you can figure it out what could be the region. So that is the thing behind it. So now we'll move to this part. So this is, I'll just continue the problem as problem number 8. Okay, fine. So now look at this one. All that what we have in our hand is your left hand side. This is going to be your x. This is going to be your 2 minus x square. So this is x square plus y square. And this is going to be your dy dx. Okay. Now what does it mean? It means that this is your y value. This is your x values. So your y is equal to x. Your y is equal to square root of 2 minus x square. So it is y square will be equal to 2 minus x square. So it is x square plus y square equal to root 2 the whole square. Because I want to bring it to the form of a circle. So you know very well that the general form of a circle is x square plus y square equal to a square. So now 2 I am writing as root 2 the whole square. So this is my y. So from the integral values of your y, I am able to figure it out that I am just drawing a line y is equal to x. So coming for your x is equal to 0 is your y axis and your x is equal to 1. So now you have to draw a circle with the center as the origin and the radius is root 2. So root 2 is something, it is some 1.4, something like that. Okay, I go on with that. So if I'm going to draw a circle, then this becomes root 2 comma 0. This becomes 0 comma root 2 and all these things. So I'm just going to draw another one thing is what? That is your x is equal to 1. And x is equal to 0 here. Okay. So this is happening here. Now the things which is common to that is, look, this will be the one. Okay. So this region is a prime focus of it. Now what I can do is, we have identified that it's a circle. So I can just go on with the r cos theta. So I can go with r sin theta. And then you go with your dx, dy. It could be r, dr, d theta. So that's simple. So now what you will do is, so you can simply go with the substitution of it. So this becomes, so which is again equal to, I will just write it here. So x square plus y square. So this is going to be your r square. And dy dx or dx dy, it is going to be your r dr d theta. So you are getting finally r cube. So you know the, what will be the radius? Your r. So definitely it is 0 to root 2. What is your theta then? See, theta is nothing but, look at this one. I'm just focusing only on this, not the entire circle I'm going to focus. So only this particular area if I'm going to focus, then you know very well, this angle formed by this one will be pi by 4 and this will be pi by 2. So this is going to be pi by 4 and this is going to be pi by 2. So what happens here? So this becomes pi by 4, this becomes to pi by 2, this becomes your root 2, this becomes your r cube, it is dr and d theta. So now I will just look back to the question here. So when you're looking back to the questions, so here you are having some m pi and something you're having as n. So one value was right, pi by 2, and 0 was fine. So the thing is actually what? Your m pi is equal to pi by 4 and your n value is root 2. So I can find the value of m to be. So I can find the value of m to be 1 by 4 and I can find the value of n to be root 2. So if I do that, what are the other options I can get right? M is equal to 1 by 4 is right. So let me check what happens when n plus n. N is equal to root 2 is not right. M plus n equal to 0 is not right. So I have to check the C option. So what is the C option here? The C option is what? Your m plus n. So your m plus n will be 1 by 4 plus root 2. So it is 1 plus 4 root 2 by 4. So let me check whether I am getting the same option or not. Okay, 1 plus 4 root 2 by 4. Yes, I am getting the same option. So I can say that my B option and C options are right. Now coming to the next one. Again, so look at the problem. See, if you are looking at the problem itself, we are a little worried. And well, maybe I can say that we will not be that much confident of what is this. It's given log expressions. And whenever we are finding the integrand complicated, we feel the problem is different. And it is difficult too. Something which I've never seen. But we just again gaze at the problem once again. But look at the thing. What is the region it is being defined as? It is a Paka circle region. And it is a circular part. It is lying between what? A circle with having your radius is 1 and again radius is E. So that the concentric part, that circular region was lying between the two circles. So that is the ultimate focus. So as I said earlier, if you're looking at the problem, please don't look with any fear of it. It's very simple and easy to solve. So move on with that idea. So you can get the Paka solutions for it. So now what is the problem? Okay, the problem is so simple here. I want to find the value of log of x square plus y square divided by x square plus y square. So this is going to be my dx dy. And now what is the thing I'm just telling you? The part which I have to integrate will be concentric circle part with this one. So obviously, first I have to draw a circle for the given x square plus y square equal to 1 and all those things. Okay, first I draw this circle, then I draw another one circle. Okay, so this becomes 1 comma 0, this becomes e comma 0. Okay, just for your understanding. Now all that is, I am just focused on with what? This particular part. So this is very important. So you know very well, to reduce the complexity of the integrand, you have to go on with x is equal to your r cos theta, and the same conditions you will be having it. Dx dy will be your r dr d theta. So since I am not going to give much on the computations, because you know very well that this is simple to follow. But here what I like to say is, look at your r values. So for theta, there will be no problem, it is 0 to pi. So r is something but your 1 to e. So your 1 to e will be there. So this will be your log of r square, and this is going to be your r square. This is r dr d theta. Okay. So this part alone I will have a computation, because you'll be having a change in your limits. So if I say that, I think you'll be able to understand better. So it is 0 to 2 pi. It becomes 1 to e. It becomes the log of r square. This is going to be your r dr d theta. See, what I'm trying to say is, if you're going to first integrate with respect to theta, the simple, you'll be left out with your 2 pi. So you'll be here with going to be your log of r square, and this is going to be r dr. So let me take your r square. So this I can take it. I can make a simple thing. This I can make it as 2 log r. Okay. So this becomes 2 log r by 2. I can take it as 1e and dr. So again, I have just simplified this one. So after simplifying this, what can you take this? You can take it as 4 pi. This becomes your 1 to e, no doubt with that. So this becomes your log r by r dr. So now what you'll do is, you will take your log r to be your t. So 1 by r dr will be your dt. So now here you must be cautious to change the limit. So what will be your log e when you're going to take it as your r? So that is going to be your t. So log e it is going to be, and again log 1 you're going to be 0 here. So then you can able to go on with that. Again 0 to 1 it is going to be there. Again it is going to be your t 2. So it is again 0 to 1. So you'll be left out with only 2 pi. So the answer here will be your 2 pi. And yes, you're getting the D option to be right. So coming this one. So look at this problem here. It is something that you have the torsion function. That is your 5 functions, your Euler function there. So how can you do this one? See, it's very simple. You have a value here. We are trying to find the value of your k by with this integral. And then they are just going to check that which of the following will be true, whether only one value is true, or they will be able to find the other values also. So now I'm not just going to go with the complete integration part, because we have a lot more problems also to go on with that. But I'm just giving you the idea of it, because there are a few other problems are there which you'll be in need of it too. So x is equal to 0 to y. So it is x y square is a cube, dy and dz. So just I'm giving you a light on it. So if I'm going to integrate, the limits are very evident. The order of integration is also so simple with that. The integrand is also is fine. So you can integrate this one. So when I'm going to integrate, you will be getting x square by 2. So you'll be left out with the y square. So again, y square is y power 4. So I'll be having 1 by 2 outside. Okay. And then y square is y power 4. So again, it is y power 5 by 5. When I apply limit as z is z power 5. So at that time, I'll be having 10 outside. So z power 5, z3 is nothing but what? Z power 8. So z power 9 by 9, 0 to 1. So I think I'll be getting here as 1 by 90. So now it is going to be 1 by k. So your k will be equal to 90. So this is fine. Your k will be 90. But check whether you are 5 of k. That is also very important. So how can you write the phi of your 90? So we have to check whether even that option is also right or wrong. So you know very well that you will be writing in terms of your prime numbers, the relatively prime, and even the powers of the prime you'll be writing. So I can write 90 as 2 into 3 square into 5. So 9 into 5, 45, 45 into 2. Now how can I find this one? So this you know very well that I can write as phi of 2. So into phi of 3 square I can have, and phi of 5 I can be having, and this will be, so I can have it as 2 power 1 minus 2 power 0 here, because it is 2 power 1 this one, and it becomes your 3 square minus 3 power 1, it is 5 1 minus 5 power 0. So 2 minus 1 will be 1, and it will be here 6, it will be 4, it will be 24. So you will be having two options are right. Okay, so this is the way that which of the following is true. So you have to be more vigilant also in giving the answers. And another one problem. So this is also another problem that it demands a little of your understanding. So it's very simple also, but when you ever look at the problem, it makes you to feel as it's complicated. So look at the y value. So you want to spot the region and you want to move on with that. Okay, so how can you make it? So it's very simple. First, let me go on with that. Your region is there. Your x square plus y square is less than 1. And then you go with your x by root 3. It is less than y. It is less than root 3x. So now what I will do is, first let me draw the unit circle. Okay. So first I'll go with the x by root 3 equal to y. So y will be equal to x by root 3 and y will be equal to root 3x. So when I just go with this, no? So how can I get the values of it? So it's very simple. If I get x is equal to 0, of course, it passes through the origin, no doubt in that. So when I take x is equal to 1, y becomes your root 3. So root 3 is something like, when I take it as a 1.7 with that, so I just draw the line like this. So 1 second. Yeah. Okay. So this is the point. And if it is going to be x by root 3, and definitely it is going to be values like this. So I am just going to go like this one. So it comes like this. Then again, I just go on with another one because it is x by root 3 and it is root 3x. Okay, fine. So this is a thing that you can able to go on with this. So what will be the region? So this will be the region. So you can take it. So this is going to be a unit circle. This is going to be 1, 0, and it is going to be 0, 1. So from x by root 3 to root 3x, you're going to have. Okay. So yes. So now what I can do with this? So what I can really go on with this, how can I find the value of this one? So it is 48 by pi. So it is a 1. I just take x square dx dy. So similarly, I'll go with my x is equal to the circular substitution and y is equal to r sine theta. And I take dx dy will be equal to r dr d theta. And I can go with the substitution of this one. So here I can make it as 0 to 1, the radius. Okay, now how can I focus on the theta value? Because one of the problems we saw, it is pi by 4 to pi by 2 we just saw here. But how can I make this one to do that? So I'll just give one basic idea of this one. So look at this one here. This one I can write it as. So your x is equal to r cos theta. So this is by your root 3. And it is less than. This is your r sine theta. And it is less than root 3 r cos theta. So you just divide throughout by your r cos theta. So you will be getting with your 1 by root 3 less than tan theta, and it is less than root 3. So what will be your theta? So theta will be your tan inverse of your 1 by root 3. It is less than theta. It is less than your tan inverse of root 3. So in your tan inverse of root 3, you can just have it as your pi by 6 and your pi by 3. So it becomes your pi by 6 and this becomes your pi by 3. Okay. So now what is your x square? Your x will be r square cos square theta, and dx dy will be r dr d theta. So again, you will be have your r cube will be there, and then you can have it as your cos square is actually what you can have it as 1 plus cos theta by 2. So all those things, it's a simple calculations if you're doing it. So you will be getting the final answer to be your 1. So I just want people to check this one, whether you are getting the same result. So coming to the next one, yeah, the volume of the solid bounded by the planes. So x plus 2y plus z equal to 2. So just if you're looking at the problem, so you have to just to say that which of the following are true. So now this also, you are not asked us to find the value of the integral actually. Establish the relationship between the unknown values. So how come it is there? So this is also very simple. As I said earlier, you have the planes. So x plus 2y plus z will be equal to 2 and x is equal to 2y equal to 0. So we'll see that how can we do that. So this is very simple. So you will be having x plus 2y equal to 2. So you want to plot this one and you have x is equal to 2y. So here, so maybe I can just take it as your x is equal to 2y, you can take, so as you take your x is equal to 0, you get 0, x is equal to 1, you get it 2. So if I just take x equal to 2, you'll have here, and it goes on. So definitely, so you will have this one. Then x plus 2y equal to 2. So just we can have an idea of it. When you take x is equal to 0, so what happens? You take your y is equal to 1. When you take x is equal to your 2, you take y is equal to 0. So it is going to be 0, 1 and 2, 0 here. Fine. So definitely this is going to be the region that we are going to focus it. So now you are going to find the value of the integral. So what is the thing here? This is going to be x plus 2y plus z equal to 2. So when I'm just going to find now, what will be your z? This will be your 2 minus of x plus 2y. And here you're going to have x plus 2y equal to 2. And here you can take the limits of your y. And again, you can take it as your x here finally. So finally, x you can take it as 0 to 1. But you just to see that you're going to find the values of your y. So you're just going to have a vertical strips over it. So this is nothing but your x is equal to 2y, and this is going to be your x plus 2y equal to 2. So this will be your y in terms of your x. So x by 2, it is 2 minus x by 2. So look at this one. And now you'll be checking with these problems. Here. So now this is going to be the values. So you can compare it. So you can compare your beta with your x by 2. You can compare with your phi to be 1 minus x by 2 and your gamma to be your 2 minus x minus 2y. So what happens when I'm just going to look into the options? So phi plus beta cannot be 1. Your beta is equal to x by 2 is correct. But when I'm going to add all those things, and I'll be getting this answer also right. So I'll be getting for 3 minus x minus 2y, because when I'm going to add 5, that is 5 plus beta, I'll be having with 1. So when I'm going to add with a gamma, so it is 3 minus x minus 2y. So that is also fine, I'm getting it. So we'll go with the other problems here. Okay. So now this is also another kind of problem that it has been asked. So what type of problem is this? And here the problem is you have a function, it is not or it is a continuous functions over there, and it is satisfying your x plus your integral 0 to x f of t dt e power minus x 1 for all x belongs to 1. Then they are asking us to what interval. So they are giving a particular an equation having an integral and all those things, and they are asking us to find what will be the values of to have an f of x component, what expression is being given there. But I'm having some f of t for which what you will do is So you can take it as your x plus integral 0 to x. This is going to be your f of e dt, and it is going to be e power x minus 1. So that is an idea. You first differentiate the entire equation with respect to your x. So I'll get 1. So if I want to have the d by dx of the 0 to x f of t dt. If I do that, first I have to differentiate with respect to the integral x, but I'm just going to have it as 0. Why? Because it is an expression of your t. So then I will be just substituting the limit with that, your f of x, and f of 0 is here, will be a 0 there. So it is e power x minus 1. So you can have yours, your f of x is going to be. So e power x is x. And here if I'm going to integrate your 1 with respect to s, I'm going to get 0 here. So I'll be left out with the e power x minus 1. So now what is given there? So it is given as 1 less than or equal to your f of x less than or equal to. So I have found what is my f of x. It is e power x minus 1, 2. So it is 2 less than or equal to e power x less than or equal to 3. So your x will be your log 2. And it is less than or equal to log 3. So this option is also serving to be the right one. So the next one is of your double integral over xy. Asking it at least one or other way. So you can take it as y square equal to x and x is equal to y. So this region is going to be there. And eventually you can change the order of integrations and you can do it. So maybe they are asking us integral xy and it is x plus y. This is going to be dx and dy. Okay. And now with the other areas of it. So this is going to be your origin and this is going to be your 1, 1. And here you can take it as. So how can I go on with this particular problem here? Now this is dx, dy. I'm just going to take it. So I want to the limits to be in terms of my y. So here it is going to be your y square x and this is going to be your x is equal to y. So now I can just have here as your xy. This is going to be your x plus y. So if I want to first integrate with respect to x, I want to get the limits in terms of y. So for which I can go on with this. I have to draw the horizontal strips like this. So the limit will be your y square to y. And this is going to be your dy. And here it is going to be 0 to 1. So this is very simple here. So now I have to integrate. So integrating part is actually, I have to go on with dx and I go with my dy. So it's very simple that you go on with here. So how can you integrate with respect to your x? So it is going to be, maybe I can take it also separately so that we can be free from the complexities I said. So it is going to be x square y and it is going to be x y square. Okay. So now I can integrate with respect to your dx. This is going to be your dx and then with your dy completely. Okay. First let me do it. And then see, it's a very simple one. When I'm going to just integrate this with respect to x, I'm going to get x by 3. So it is going to be y. And again, I'm going to integrate here. I'm going to get x square by 2. And then I'll be having your y square. And I'll be applying the limit. So it is again, I will be getting here a 0 to 1. So if I'm going to do that, then it is going to be x cubed by 3, as I said earlier. So this is going to be my y. So I have to apply the limit. It is y square y. And again, I'll be having x square by 2. And then it is going to be my y square. And this is going to be my y square by y. And it is going to be my dy. So I'll be getting the entire expressions in terms of what? My y. So once I'm going to get the expression, so I think I'll be getting the expressions of, I'm just, I'll write it. So I'll be getting some y power 4 by 3. And it is going to be y power 4 by 2. So minus y power 7 by 3 minus y power 6 by 2. So if you people are just working on it, then I have to integrate then with respect to y. So if I'm just having an expressions of it, I'll be getting here as 1 by 15. So the final expressions is 1 by 10 minus 1 by 24 minus 1 by 14. So this part will be the 5 by 6 one. This becomes 24 minus 1 by 14 So 624 and all those things, if you're just going to bring about that, the calculations. So check whether you're getting the 3 by 56. So this is the problem that we have to just solve when you're doing that. And the next one is, so this is also a very simple problem. The volume of the solid which is bounded by the cylinder. So now we are coming to the cylinder part of it. And the cylinder part, you know very well that the base and the top, they are actually circular in nature. And again, the center part will be the given here as a planes y plus z equal to 1 and z equal to 0. So this is how the cylinder has been defined with that. So how to go on with that? So this is going to be your V. Your V is going to, because you are going to find the volume. So it is dV. So again, you can have it as your dx, or you can have it as your dy and dz. And what is your z? So actually, it is given that y plus z is equal to 1, your z equal to 1 minus y. So it is 0 to 1 minus y. So this part is subject to a circular region. So if I'm going to integrate with respect to z, I'll be getting, so 1 minus y. So this will be the part, and again dx dy. So now this will be again equal to your double integral dx dy, and this becomes my y dx dy. So look at this one, the dx dy will be part actually what? It is given the circular region is x square plus y square equal to 1. So what will be the area of this one? So the region will be your pi a square, so a is equal to 1. So coming over here, will be, so your y will be, now it will be like square root of 1 minus x square plus or minus. So you just take it with the minus 1 minus x square. So it is 1 plus x square. So this will be your minus 1 to 1 finally. So here you will be having your y dx dy. So you can change the order of integration. And if it is the case, it will be dy and dx. So here, if I'm going to integrate first with respect to y, it is going to be y squared by 2. So you know very well that it is an even function. When I'm going to apply this particular limit, this entire integral will be getting vanished off. So I'm left out with the answer as pi. So this is the answer over here. Then next we are dealing about the cardioid. So cardioid is another one problem that, so you're taking with the r equal to a into 1 plus cos theta. So they are just asking you to find the surface area. So now, if you're going to find the surface area, it is given in terms of your z, x, and y, then you have a different formula. But here it is given in terms of the polar form. So I'll just go on with this. So you know very well that this is going to be the cardioid one. So your r is equal to a into 1 plus cos theta. Okay, now if in terms of z it is given, then you know very well that it is double integral over the particular region, so dx dy region. So you have square root of 1 plus zx square zy square. And now it is given in terms of your polar coordinates. You just take it, yes, there is a formula for it. So s is equal to integral. You have it as 2 pi r sine theta into square root of r square dr by theta the whole square into d theta. So I just give some time for you to understand the formula to find the surface integral. So it is only with respect to theta. So that is very simple. And listen here, you are going to just take about the initial line of it. Okay, so the initial line will be just 0 to pi. So you just go with your 0 to pi. So 2 pi is actually the limit. So you have take it as 0 to pi. And what is your r? R is nothing but 1 plus a cos theta. So this is going to be your sine theta. And this is going to be your r square. It is 1 plus a cos theta the whole square. And dr by d theta. So what is your r? R will be your a 1 plus cos theta. So your dr by d theta will be your minus a sine theta the whole square. So you go with your plus, and again it is going to be my d theta. So if you just, I'll give you a second. So just see that how can we make this integration very simple. If you're just looking at it, you will have an idea. So if you're looking at this particular one, you may find certain similar terms in it. So let me just tell you what is that. So it is going to be your 2 pi and it is going to be your 0 to pi. And here you can have it as, so it is 2 pi into your a will be your 1 plus a cos theta. So then you will be having here as, okay. I think I have just made a mistake in writing the expression of r here. So r equal to a into 1 plus cos theta. So I have written as 1 plus a cos theta. So okay, fine. So now it is going to be my a square into 1 plus cos the whole square. So this is going to be the things. And here if I'm just going to that have a, and I think in this root I'm going to have a square is common. So I think I can write it as a square. So now this becomes your 1 plus cos theta, and here becomes it is your sin theta. And here again it becomes your a square. So it is a 1 plus cos theta the whole square. And this becomes your sin theta the whole square. So you have it here as d theta. So now how to go on with this? See, we are not going to have the complete integration part now. So we can make it a bit simple here. So this is going to be my 2 pi a square. So now what happens here? So I'm just going to have it as 0 to pi. So here it is going to be 1 plus cos theta, and this is going to be sin theta. So look this one. So what I can do here is, so I'm going to have it as it is 1 plus cos square theta plus 2 cos theta, and this is going to be my sin square theta, and here it is d theta. So it is 2 pi a square, and it is going to be 0 to pi. So it is 1 plus cos theta, so into sin theta. So here again it becomes, it is cos square plus sin square is actually 1. So it is 2 plus 2. So I can write as 2 plus 2 cos theta. This becomes d theta. So it is 2 pi a square. So I can take it as outside becomes root 2. So it becomes 0 to pi. So it again 1 plus cos theta. So it becomes sin theta. Again it becomes 1 plus cos theta, the whole part 1 by 2 d theta. So here I can take it as, it is 2 pi a square into root 2. So it becomes 0 to pi. It becomes 1 plus cos theta. So the whole part, it is 3 by 2. This becomes sin theta and d theta. So what happens here? So I can take it as 1 plus cos theta to be your t. And I can take it as minus sin theta d theta will be equal to your dt. So I can take this one. So what happens to the limit? So if I'm going to take 1 plus cos pi, so cos pi value will be actually what? Minus 1 here. So it will be 0. So here I'll be having this 2. So I can take this as, so it is 2 root 2. It is pi a square. So I can take it as 2 to 0 there, because respectively I'm getting it. And I'm getting one negative value because 1 plus cos theta I'm taking it as t. So it is t part 3 by 2. Sin theta theta is dt. So now what I will do is, I'm just going to change the limits from 0 to 2. So I'll have a negative sign. So it gets divided down. So it becomes positive here. So it is 3 by 2. So again, it is 2 root 2 pi a square. When I'm going to integrate that, I'll be getting 5 by 2. So again, it will be 2 by 5. So t to the power 5 by 2, it is again 0 to 2. So I can have this as 4 root 2 pi a square by 5. So I have to get it as 2 5 by 2. So I'll be getting the root 2 into 5. So I'll be getting is actually what? The final answer when I'm just going to go on with that. So I can able to get it as 32 pi a square by 5. So this is the way that you have to solve the particular cardioid problem. And another one problem here, this also is very simple and easier one, that where you can go on with this. So if f of pi equal to 2 and 0 to pi f of x plus able derivative of x of sin x dx is equal to 5, we are asked to find the value of f of 0. So this is also very simple, But if you're just looking at that, it will be like a nightmare that how you can able to solve your f of x and f double dash of x, all those things. But let us go in a step by step to have a simple understanding of the solution to the problem. Okay, the first one is, so you are going to just take 0 to pi f of x, and then I can take it as 0 to pi. I'll have it as f double dash of x, and it is going to be sin x dx equal to pi. So sin x was common to both the terms, so I'm just putting as two integrals. That's it. Now let me go on with that. So here in this case, I can take it as u equal to f of x. So I'll be getting du will be equal to f dash of x. Then I'll be taking as dv will be equal to your sin x, and your v will be equal to the sin x dx. V will be equal to minus cos x. Now, so uv you'll be taking this. So you'll take it as uv. So plus integral v du. So this will be your f dash of x, and this will be your cos x dx. So you just take it as 0 to pi. So again, you have to apply the limit of 0 to pi here. So this becomes again 0 to pi f double dash of x, and it is sin x dx is equal to 5. Okay. So now what happens here? So f of pi is equal to 2 here, and your cos pi value is actually your minus 1. So this becomes your 2. Again, 0 cos 0 is actually f of 0. You have to find the value. So you are just left out with f of 0. Okay. So f of 0 cos 0 is 1. So 2 plus f0 is retained with that. So this becomes again 0 to pi. This becomes f pi. It is your f double dash of x, and it is going to be your sin x dx is equal to 5. So now we are just going to repeat it again to this particular part. So again, I'm just going to take your u and v. So again, you will be taking your u will be equal to your dash of x. So your dv will be equal to your cos x dx. So your du will be equal to your f double dash of x, and your v will be equal to your sin x dx. I'm sorry, you will be taking only your sin x. Your dv will be your cos x dx. So you'll be getting your sin x. So again, it becomes your uv. So uv will be your f dash of x. Will have your sin x. So it is minus again integral 0 to pi. That will be your f double dash of your x v du. So this becomes your sin x dx. So now you will be understanding why are we doing like this. Okay. So it is again sin x dx is equal to 5. So now it is left out with actually 0 to pi. Now it is actually 2 plus f of 0, and actually this is f dash of pi. So this is sin pi and sin 0. So obviously, luckily now we are getting a sign expression. So this will be vanishing at all. We need not worry about this particular expression at all. So we can simply move on to this one. So what is this particular one? So 2 plus f of 0 will be equal to your 5. And your f of 0 will be equal to your 5 minus 2, that is equal to 3. So now you have got the value of your f of 0. So the first options we are getting it. Next, coming on the next one. So you are getting another one problem. We are using the transformation. So it is given directly that you have to use a transformation. So if you first look at the problem now, you feel as though both are like. But if you're just going with the deep, the first integral, the limit with respect to your y is from 0 to 2. And again, the limit with respect to your y in the second integral, it is from 2 to 3. So this is where we are lying distinct in this particular problem. So this is very simple. And let me just give you an idea. So you will be able to easily understand what this problem is all about. So it's very simple. So then integral is actually given like this. So what is that? It is actually 0 to 2. It is root of 4 minus y square. So you know very well that it is a circle. So it is 2xy dx dy. So the same thing you have it for your 2 to 3. And the rest of it follows the same way. The order of the integration is not changed. So now, look at the very first one. First, we'll draw the circles. Actually, your x is equal to 4 minus y square, and another one x is equal to 9 minus y square. That is your square root. So your x square plus y square equal to 4, and your x square plus y square equal to 9. So now what happens here? So now I'm just going to draw a circle. Circle, the center is actually the origin, and of course the radius is actually 2 square. So there's going to be a circle with the radius 2, and another one a circle with the radius 3. I'm going to have it. So now look at this one. So this is going to be your y. So y is equal to 0 is your x-axis, and this is going to be your y is equal to 2. So what is the next one? Again your y is equal to 2 here. Then again your y is equal to 3. So now it is very simple that you go on with this distinctions. So the first way, you will be coming with this one, because this is your 0 to 2, 1. Then another part is this one. So you want to sum up with all those things, and that way you are subjecting only to this particular region of it. So your first quadrant, you're just going with that. So you are going to make it up. So only this part you're going to post. You're not going to focus on this particular one, and here only this region is there. So now you are going to just make into consideration of this. So what can you do this? So you can do it actually. You can make this as okay. So you can make one particular one here. So in this one, you can take up the region between your concentric circles only with respect to your the xy plane. So in that case, so just so once again, I think okay, it's got a bit jam over it. So fine. So now I think this particular region you are just going to have a focus of it. So now how can you do this one? See, it's very simple. In the first case, I'm just going to focus, as I said, is 0 to 2. And again, in the next case, I'm just going to focus about on your 2 to 3. So in this particular problem, we are going to make use of only the one thing. If you're going to look at the options over here, it's a simple. So look at the substitution of it. It's 2xy and dy and dx dy. So that is going to be your double integral, and you can take it as your 2. Your xy will be your r cos theta, and it is r sin theta, and dx will be your r dr d theta. And look at your it is will be 2 to 3. Only in the first quarter, so you just take it as 0 to pi by 2. So what happens here? It is 2r cube you can have it as. Then your cos theta sin theta. So if you're looking at the options, I think it is sin 2 theta. You can have it as an take the C options to be the right one. Yes. And now coming to the next problem. So these are some of the most anticipated problems list. So there are various problems are there where you can expect. So I think these set of problems also they are falling in line. So now how to deal with this? If you are just looking at the problem, so look at the value of the limit of an integral. It is given in the numerator. So that makes us a bit complicated there. So now how to deal with this particular problem? See, look at the first one. You are going to apply the limit extends to 1 by 2. See, plainly we can just have a discussion before penning down. See, if I'm going to apply x is equal to 1 by 2 in the denominator, what happens? So it becomes 1 by 4, because here now you can have this as e power 2x. So you take 2x, when at x is become 1 by 2, it becomes e by 2. So when you are putting x is equal to 1 by 2, it becomes 1 by 4. So 1 by 4 plus 1 by 4. So again, the denominator is becoming 0, and obviously it is getting vanishing also. then even when your extends to 1 by 2, 1 by 2 to 1 by 2, no, of course, that is also a problem that you are not be getting a specific value with it. So now what happens? So whenever you are getting this case, then automatically we start integrating, right? That is going to be 1 by 2x, and then you're going to have it as your cos square pi t, and you're going to have it as your dt and all those things. So now I'm going to differentiate this particular one. So what happens first? I said earlier, now it is a function, so I'll take it as 0, and this becomes your cos square, your pi x. And suppose in case if you put your 1 by 2 here in the place of your t, then it becomes 0. So I'm not worried about that. So my denominator, it will be coming as, actually you'll be having e power 2x by 2 in the denominator. So minus again, it is x square plus 1 by 4. So what happens if I'm going to differentiate? So e power 2x into 2. So again, it cancels, so e power 2x will be having. Then in this case, I take 2xe. Now what I want to do is, I want to have my limit extends to 1 by 2. So if I take extends to 1 by 2, it becomes e, again, of course, it goes on. I'm getting indeterminate form, I'm just getting it. So I cannot go on with this. Even in the numerator, the same condition is there. And now what happens over there? So I can just go on with the repetition. So if I'm going to again differentiate both the numerator as well as the denominator, then automatically I'll be getting the other simplified expressions. So if I'm just going to do this one, okay. So in the flow I have written as pi by 6, so it's pi square x, so it will be lines. Then again, if I'm going to differentiate the denominator as well as the numerator, if I'm doing it, and this becomes a again 2 cos minus 2x. So minus, if I just going to have it as, it is going to be 2e. So again, if I'm going to apply the things, no, so I become what happened here is, it is 2 cos pi x and a sin pi x. So I can have this as sin pi x. So sin 2 pi x I can have it. So I can have it as minus pi. This becomes sin 2 pi x. I can have this one. So I can return the expression as 2x minus 2. So again, if the denominator, again, x is, so this one, if I'm going to differentiate, it becomes cos 2 pi x. Of course, I go with one more 2 pi will be here. So this will be 2 pi square. I have a negative sign. So again, this is going to be here. So now if I'm going to have is my x is equal to pi by 2. So I think I'll be having here as minus 1 cos 2 pi square by 4e. So I'll be left with the 2 pi square by 4e, and I'll be left out with the pi square by 2e. So this is one particular result you are going to have. This is a value of it. So another one. So you have D is a container R square. It is a closed disk, and center of the origin and radius. To find the value of it. So whenever you are having the radius is 2, then you can go on with that very simply. So I can take the integrand one. It is double integral over D. It is e to the power minus x square. So it is D. So it is e to the power x square plus y square. So it is going to be dx dy. So here I can take it to be the circle. So it is given x square plus y square is equal to 4. So you can make the use of the circular polar coordinates. So x is equal to, you can have it as r cos theta, and y is equal to your r sin theta, and you can take your dx dy will be r dr d theta, and you can make all substitutions, and I think you will be getting with the e power minus r square, and you will be having it as r dr d theta. So you can take it as r square as t. So you can take it as 2r dr dt. So it is going to be 0 to 2, your r, and it is going to be 0 to pi. So essentially, you can make some changes in the limits because you're taking r square equal to, so it becomes 0 to 4. Then you can make all other integrations as the same way. and the final result you will be getting as pi into 1 minus e power minus 4. So I like to move on to the another problem because we have a very short span of time. So what is this one then? So this is again, I'll be telling you another one problem that where the integration aspect is more important. See, it is not simply that you are finding a value. You want to know the nuances and techniques of integrating these things. So I will just give an idea of it. And then later you can move on with this. So the problem is actually your a root 3. So again, it is x square plus a square. This becomes 1 by y square plus x square plus a square. This becomes x dy dx. So now what happens here is, see, I'm just going to consider this. So I'm not going to directly integrate with respect to x or y directly, but I'm just going to make some sort of adjustments here. So whatever adjustment I can make is, I'm just going to make this as 1 by y square plus root of x square plus a square the whole square. So I'm like to bring the form of 1 by x square plus a square. So I can take it as 1 by a tan inverse of x by a. So that formula with respect to y I'm taking. And in this case, I'm going to take my entire a to be what? Square root of x square plus a square. So it is going to be a root 3. So with respect to y I'm doing it. So 1 by a. So it is 1 by root of x square plus a square. And this could be your tan inverse of y. So y by what? Y by a. So y by square root of a square plus a square. So I just like to apply the limit to this one. It is 0 to root of x square plus a square. I'm left out with my x dx here. So what happens? So in this case, I'm just going to take it as 0 to a root 3 I'll be having. And I can take it my x root of x square plus a square I can have. So tan inverse of this will have be 1 minus again 0. So I'll be left out only with this. So I take this as my dx. So now I can take one adjustment of x square plus a square. I can take it as t square because I want to integrate this one. So I can take it this as 2x dx will be equal to 2t plus my x dx will be equal to t dt. So I need a change of the limits. Am I right? Because when my x is equal to 0, my t square equal to a square, so t equal to a. When my x is equal to a root 3, x square will be equal to 3a squared, so 4a squared, so 2a. So I can have it as a to 2a, I can have it as, and this I can have it as t dt. This can have it as root of t square, so it will be t. So I can have this as, already I'll be having on pi by 4 because my tan inverse of 1. So I said, but I not make a note of it here. So you can have your pi by 4. So pi by 4 will be there. So t dt. So again 2a minus a will be a. So it is a pi by 4 or pi a by 4. So this is another problem. So we'll go on. Actually, I'll have only very few problems are there. So just 3 problems will wind it off. So the value of the double integral over root of x square plus y square lying in the region where xy plane bounded by this one. See, already we have done a problem of this kind. So it is 2 and 3 we have done it. So problem, but the only problem is your integrand is square root of x square plus y square. So I like to just throw one light on it. How you can tackle this problem will be, so basically you go with like this. So it is 2 to 3. So it is going to be your 0 to 2 pi. So the same problem, it may be in a different sense you are asking by changing the integrand. So x square plus y square, so this will be completely change the root of r square and r dr d theta. So on solving, you'll be getting the answer is 38 by 3. Okay. So we'll go with the next question. So this is a question that we'll need to focus on because it works on a formula. Okay. So now evaluate. So whenever you are getting the integrand like this, don't get panic. If you are getting the integrand of this form, then it is very easy to solve by using the below expressions that what you're going to see. So you're going to evaluate the particular integral of some x to the power minus 1 by 2. So some power values you are having and all those things. So how to do this one? So it's very simple. And so you can take it as whenever you are getting like this form. L minus 1, y to the power n minus 1, z to the power n minus 1. And it is going to be f of plus y plus z. So you can take it as dx, dy, dz. Fine. So you have an expression of this form. Okay. So this will be, I can write as gamma of L, gamma of M, gamma of N, and it is gamma of 0 to 1, and it is u power L plus M plus N minus 1, your f of u du. So now very well, look at the particular problem over that. The problem is nothing but your triple integral minus 2, then 1 z minus 2, and it is 1 minus x minus y minus z 1 by 2. So in this case, I can express this as. So I want to give an equivalent expression. So I can take it as half minus 1, y power half minus 1, z half minus 1. So it becomes 1 minus. So it is x plus y plus z. So this is going to be dx, dy, dz. Okay. So now I can make this expression as gamma of 1 by 2, gamma of 1 by 2, gamma of 1 by 2. It is gamma of 1 by 2 plus 1 by 2 plus 1 by 2. So it is L plus M plus N. So again, I can take it as 0 to 1. I can take it as u power L plus M plus N minus 1. So 3 by 2 minus 1 is 1 by 2. So 1 minus u. So I can take the entire function to be, it's u now, because I can take it as a function to be u. This becomes du. So you know very well the gamma function. So it is gamma of 1 by 2 will be equal to root pi. So I'm getting gamma of 3 by 2. So gamma of 3 by 2, I can write as gamma of 1 by 2 plus 1. So it is 1 by 2 into gamma of 1 by 2. So I'm able to get the answer this is. So here I'll be getting it as 2 pi by simplifying this one. So 0 to 1, it is u power 1 by 2, and it is 1 minus u to the power 1 by 2 du. So what happens here? It looks like you got beta function, no? So what happens? You can take the gamma n, gamma of m plus n. So the beta functions, you know very well, it is 0 to 1, x power m minus 1, 1 minus x, n minus 1. So it is dx. So here in terms of it is du. So you can apply the formula, and you can check the result also. So you will be getting finally pi square by 4. So I think the last problem will just being seen now. Yeah, the volume of the closed region bounded by the planes x is equal to 0, y is equal to 0, and then you have another equation of the planes. So how could you find the volume of it? So if you are just looking at the problem, there is a simple way of doing this. So giving such a plane equations of it. So you are getting 2x plus 5y plus 10z will be equal to your 10. So you are just going to divide throughout by 10 and putting it into the intercept form. So you go with your x by 5 plus y by 2 plus z by 1 equal to 1. So in this case, you can take your x by 5 because you have one particular formula. Let me just give you the formula, then you will know we are writing like this. N minus 1 dx dy dz. It is going to be gamma L, gamma M, gamma N, and it is going to be gamma of L plus M. Okay, so these are some standard results are there. We can make use of it. So this becomes your u part, this becomes your v part, this becomes your w part. So your x by 5 is equal to your u. So you can have your dx to be your 5 du. Then again y by 2 equal to your v, and dy will be equal to your 5 dv. And you can take it my dz by 1 is equal to your w. So dz is equal to dw. So once you are substituting here, in this case, you don't have any expressions of that. So it becomes your triple integral 5 du, 2 dv, and dw. So this becomes your 10 integral du, dv, and dw. So you don't have any expressions of x, y, and m. So you take your L, m, n. So 1 minus 1. So I'm giving the expression as, I can take this as x power, I can take it as your u power 1 minus 1, v power 1 minus 1, w power 1 minus 1. So it's going to be du, dv, and dw. So you just see that what you're getting finally. So you are getting is gamma of 1, gamma of 1. So gamma of 1 is actually 1. So you're going to be gamma of 3 plus 1. So gamma of 3 plus 1 is going to be your gamma 4. So it is 3 factorial, will be getting it. So here you have it as 10. So it is 10 by 6. It is going to be 5 by 3. So we have discussed so many problems of different way. So some are actually based on the formula, and some are basically having an understanding about properties and nature of the solutions, what is being given there. And the problems are very simple. As you are understanding, whenever you are looking at the problem, you have to graph it. Once you graph the problem, then you'll be able to understand much better how to approach and how to find the limits of it. So thank you for your patient listening. And I think it would be really beneficial for you people. And if Sir will be certainly sharing the recorded lectures of it, I think it will be really fruitful for you people if you are having the regular practice of these problems. So thank you so much. And thank you, sir, for giving me a wonderful opportunity to address the aspiring students.
Dear students, now it is the time for feedback. Please share your comments about the session.
Hi, ma'am. I'm Adira from Government Victoria College, Palakkad. Actually, your section was so helpful. It discussed a lot of problems which were just small, lightly aware of. So, looking for more classes, ma'am. Thank you so much, ma'am, and thank you so much, sir.
Thank you,
Thank
Adira. Yes, others.
Hi, ma'am. I'm Parvati from St. Teresa's College, Kerala. Thank you for giving us such a wonderful session. The session was really helpful. It helped us more how to solve problems. So we are looking forward for more sessions. And thank you, Vinod sir, for such a session, for holding such a session. Thank you.
Okay, thank you, Parvati.
Hello,
Yes.
ma'am. I'm Soumya from M.A. College, Ernakulam, Kerala. Your class was wonderful, ma'am. You discussed many problems that we were unaware of. So we are looking forward for more your classes. Thank you so much for Vinod, sir. Thank you for conducting the class.
Thank
Okay,
you.
thank you, Soumya.
Hello, sir. Hello, ma'am. I am Aditya Krishna from Government Victoria College, Palakkad. Your session was very interesting and very helpful. Thank you so much, ma'am. Thank you so much, sir.
Okay, thank you, Aditya.
Hi,
Hello,
ma'am.
ma'am.
Here from Assumption College. Your class was very wonderful and you explained the concepts and questions very clearly. Thank you, ma'am, for the session, and thank you, Vinod sir, for the class.
Thank you, Aishwarya.
Hello, ma'am.
Yeah, Sharad.
Hi, sir.
Ma'am, thank you for the session. Actually, thank you for including so much examples and questions. And thank you, Vinod sir, for organizing such a wonderful session. Thank you so much.
Thank you, Sharada.
Hello, ma'am.
Yeah, Akita.
Hello, ma'am. I am Akita from TMC College Tirur. Today's class very nice and interesting. You explain each and every topic clearly. Thank you so much, ma'am. Thank you so much, sir, for this class.
Thank you, Akita.
Hello.
Yeah, Nivetha. Yes.
Hello, ma'am. I am Nivetha from St. Mary's College, Tamilnadu. It was a nice session, and through the session, we were able to know more about integrals and especially double integral problems that most probably occur in JAM examinations. Thank you so much, ma'am.
Okay, thank you, Nivedita. Yes.
Good afternoon, sir.
Yeah.
Sorry for joining late today because of some problem. The lecture was very nice, and I attended last problem, which was related to beta gamma problem. That was nice problem. Can you suggest some books for integral calculus also, and your research journey? Tell about your research journey also.
Sir, actually, there are problems books are there, but not specially for integral calculus. Sir, you have a solution books comprising all the problems spreading over the entire syllabus of your exam. And what I feel personally is more than moving, refer to the books. There are so many online resources are available in plenty. That the thing is, we have to spend our time and get to know things. Because some people are very seriously preparing, and repeatedly so many YouTubes are being recurrently they are putting it. All the problems they are solving then and then in different perspectives are there. So we can look into it and we will have a very clear idea of it. Because I should, at this juncture, I should really mention it. A special word of thanks to sir, because only after sir giving me an opportunity of stepping into math aspirants, and we are getting, as teachers itself, we are getting an opportunity to at least refer these problems. Okay, how far they're asking, because We will be taking the problems in a very simple or lightweight to the students for their understanding. But when come to the competitive level, so how they can able to increase the intensity of the problem, the difficulty and complexity in solving it. So various things. So this is also a kind of learning for us, and especially learning for me, I should say that. So after coming that, then I am teaching so many extra problems in this way. Suppose if they're asking the integrate in this way, region is of this kind, what you will do, all those things. So the only thing miles to get to know about the problems. So all problems are similar. They are not much different or distinct, but only the thing is a little bit of difference lying in each of the problems.
Yes, sir. Thank you, ma'am. Thank you, sir.
Okay, thank you, Dharmendra. Others?
Hello, ma'am.
Yeah.
Hi, Atulya.
Hello, ma'am. I'm Aditya from Kerala. Today's session was really helpful. You explained all the solutions very well. Thank you, ma'am. Thank you, ma'am, for the session.
Okay, thank you, Atulya. Yes.
Hello, ma'am. Good afternoon, ma'am.
Yes. Yes.
Good afternoon, ma'am. Good afternoon, sir. Ma'am, your session was really wonderful today, and the motivation that you gave us, it will keep us motivating till the end of the examination. And the practice session that I took today, it contains a lots of question, and it will definitely help us at the end of the exam. Like right now, we are like going through the practicing questions a lot. So these collection of question will help us a lot. Thank you, ma'am. Hoping for more such session from your side. Thank you, sir.
Okay, thank you, Shikha.
Hello, sir.
Yeah. Yes, Kishore.
Yeah. Good morning,
Yes,
sir.
Kishore.
I'm very happy to attend this lecture. I'm a Ph.D student of ISPVM first year, and I'm from Madurai, Tamilnadu. I'm very happy to attend this session. Like, I'm very to recall the problems that we have attended in the exams, especially in 2023 problems. There are many problems, and the ma'am told like if the question is easy, you have to very careful in the way. Like, we made such mistakes, like those, especially the question like surface area, that thing. Like, she is pointing out the steps which is to be, we need to be very careful. It was wonderful. Like, your lecture was very great.
Okay, thank you, Kishore. Dr. Nivetha, Kishore is from your place, Madurai.
Yes.
Yeah, he is currently pursuing integrated PhD at ISER Tirur.
Oh, fine. Best wishes, my boy.
Yeah.
Yeah, thank you.
Thank you, Kishore.
Thank you.
Yes, Aparna.
Hello, ma'am. I'm Aparna from Kerala. I'm currently preparing for NET exam. Today's class was very much wonderful and very much informative. You explained each and everything in very much detailed manner and in a simple way. Thank you so much, ma'am. Thank you so much, Vinod sir, for this
Thank you,
session.
Aparna. Any others? If any of you would like to share a feedback, please share it now. Otherwise, we will wind up here.
Ma'am,
So, yeah.
There's a question like the domain of logarithmic function is the set of all real numbers, right? Greater than 0.
I'm not able to hear you rightly. Could you please kindly come again, or you can type us a message because it's not much clear, the voices.
Sidal, could you please repeat your question?
Yes. I'm basically saying that the domain of logarithmic function is the set of all real numbers which are basically greater than 0, right?
Maybe in which problem?
Like I don't recall that problem. There is something like calculated part, like log of x square plus y square upon something which is varies in between 1 to
You
a
are
square.
talking about the integrand as a log, the double
Yes,
integral
yes,
log of x square plus y square. Am I right?
Yes, yes, yes. Please, so like, would you kind enough to show that screen?
Okay, in that problem, you have the values of things is belonging to R. Yes.
So the justification is why in between 1 to e square. So
they are just giving the particular values of your concentric region. It is not actually lying toward your e square, but they are giving that region is lying between these two things.
right. Okay.
Yeah.
Okay. Okay, thank you. Yeah, ma'am, you are unstoppable during throughout your lecture. Like nearly 2 hours, you are unstoppable.
Okay, thank you, Sudhir. Okay, once again, thanks to Dr. Nivetha for again being with Math Aspirants community. I'm sure that today's session was really helpful for many students who are seriously preparing for these exams. Thank you, ma'am. Thank you.
Thank you so much, sir. I should really thank you for giving me this opportunity and hoping to continue in the coming days. So thank you so much, students.
Thank you. Let us wind up here.
Thank you so much for all your feedback.
Yeah.
Thank you, sir. Thank you.
Thank you.